In this lesson, we're going to be taking a look at graphing exponentials. Previously, I've had you graphing exponentials, but I've always given you this parent function to start with, so that you could always be looking at that while you made it. And the questions you're going to be seeing now are going to ask you to graph the exponential, but without being given this. So you're going to have to actually know what this is yourself, and then be able to go and start applying that in the graph by seeing it in your head. So a few things that I want to make sure that you remember here out of this particular graph. One, notice we have the dotted line here at 0. That dotted line has a formal name. It is called the asymptote. That basically in mathematics means a line that the graph will approach but will never actually touch. And because the graph, as it heads over to the left here, gets closer and closer to 0 but never actually ever hits 0, that's why we put in the dotted line, and also then why it's called the asymptote. From there, our very first point that we tend to plot is this one right here at 0, 1, because anything to the power of 0 equals 1. And then from there, we start plotting other points. So then the next point we plot tends to be right there. The way that I always think about this is you're now doing 2 to the power of 1, which means we're taking whatever we had before and we're multiplying it by another 2. 1 times 2 is 2. And so that point ends up being up 2 after going up 1 at the start. The next point, notice that is going to be 2 to the power of 2 because my x value is 2 now. 2 squared is 4. And you'll notice here that if I doubled my last height of 2, I get 4. What about if I do another point here? If I go over one more x, notice I'm up there all the way at 8. The reason is because 2 cubed equals 8. Notice that as I go down this progression here, 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. And I could keep getting how high the next point is by just multiplying it by another 2. Because, of course, that's what 2 to the power of x means up here. 2 to the power of x means 2 times itself x number of times. And so every time x increases by 1, it means I'm multiplying by yet another 2. And so our height doubles. All right, now if you have that picture firmly in mind and that pattern firmly in mind, then doing the rest of our graphing should go fairly smoothly because you now have the picture in your head of the graph and how it behaves. So let's go ahead and take a look at an equation that we can graph then. So here we have negative 2 to the power of x minus 5 plus 7. Now the first thing I want you to note here is very specifically that this negative, it does not mean that the 2 is negative. It's not like doing this. Instead, it's saying that the 2 to the power of x minus 5 is negative. So we actually have to do the exponent first and then apply the negative to it. The only way that you could have it a negative 2 to the power of is if you did in fact write the parentheses in there. Without the parentheses, then the negative applies after we do the exponent. All right, so knowing that, then we can start thinking about the transformations of this. So first up, that negative is a reflection across the x-axis. And then that minus 5, it's in the exponent. Notice that means it's with the x. And anytime we subtract directly from the x before anything else is done, it shifts it over that amount. And you may recall that minus shifts to the right, plus would shift to the left. And then that plus 7 hanging on the end, that's going to shift the whole graph up 7. Now, you don't, strictly speaking, have to write all this out longhand yourself. However, it can be very helpful to do so. All right, so now seeing that, in order to make our exponential graph, the very first thing that I would suggest you do is draw in the asymptote. Now, the asymptote, remember, is a horizontal line. The only way we can move a horizontal line is if it moves up and down, because moving a horizontal line left and right leaves it in the same place. So the up-down movement is what we're particularly worried about at the moment. That's where we want to start. And so since the whole graph is shifted up 7, the asymptote is also going to be up 7. And so I'm going to go ahead and draw in the asymptote first. Now that I have that drawn in, I don't need to worry about the shift up 7 anymore because the dotted line is my reference. I can see it there. All right, from here, normally I would put my first point right there, up 1 from the asymptote. But I have this reflection across the x-axis. So instead of it being up 1 then, well, that means that it actually has to be down 1. Okay, so that means I'd be starting there, right? Well, almost. Remember that the graph is also shifted right 5. So I need to take that point and I need to drag it to the right 5 units. That then is where my first point would be. So you want to start by drawing that point in where it's down 1 because of the reflection and right 5 because of that shift over. Now that I know that, I can go ahead and just start doubling my distance. Because remember, it's 2 to the power of x. And so this one is down 1 unit. So my next has to be down twice as far. So it's going to have to be down 2. And then the next point after that will have to be down twice as far as that, which will then be down 4. And so you see that if I just keep doubling those distances, I can end up seeing where that next point will lie. Now, notice I just went down 8. Well, if I double 8, I get 16. And yes, down 16 will actually fit on my graphing grid, and so I have to plot it as well. Now that I have that pattern of doubling as I go to the right, I can now go ahead and sketch in the rest of the graph from there. Then that graph is complete. We're now going to take a look at one more like this. So in this case, we have y equals 3 times 2 to the power of x plus 1 plus 4. Once again, notice the multiplication by 3 happens after we do 2 to the power of x plus 1. All right, so let's start by figuring out what are those transformations. The 3 here, the 3 is a vertical stretch by a factor of 3. The plus 1 is going to be shifting the entire graph left 1, because notice it is up with the x, and anytime it's right with the x, it moves it in the x direction, and plus goes left. And then finally, the plus 4 is going to move the entire graph up 4. Now, of those 3 transformations, the very first thing I want to do is use the one that tells me where the asymptote goes. The asymptote, remember, changes only when I move the graph up or down. So in this case then, that's going to be the plus 4. So first thing you want to do here, draw in that dotted line, and yes, it should be dotted, up at 4. From here, I now need to figure out where my points go. And again, knowing where they normally go is so critical here, because normally my first point would be up 1 on the y-axis. But I'm multiplying the whole thing by 3, which means that up 1 gets multiplied by 3, and so 1 times 3 is, well, 3. And so that means that I'm now up at 3 for that first point instead. But I still haven't used the plus 1. Remember, the plus 1 shifts the entire graph left 1, and therefore my first point will then be right there. So again, I took whatever it normally is, which is up 1 there, I multiplied that by 3 in order to go up 3 times as far, and then I moved that left 1 because of the plus 1. Having done that, we can now go ahead and worry about where the next point goes. This is still 2 to the power of x, and since it's 2 to the power of x, I'm still going to be doubling my height as I go along. And so if that point's up 3 units, the next point will have to be up twice as far, and 3 times 2, of course, is 6. Therefore, the next point will have to be up a total of 6. Now, notice I'm counting that 6 from the asymptote. We're counting from the asymptote whenever we count these out. And so I have a couple points for my curve. Now, obviously, I'm not going to be able to fit any more going off to the right there because I'm off the grid. However, if you do want to plot some more points so that you can be a little bit more accurate, you can use that same pattern. heading off to the left. Because here we have our height of 3. Well, if I double as I go to the right, that means I'd be cutting it in half going to the left. Half of 3 is 1.5. So if you want to, you can actually even figure out exactly where those are going into the small direction as well by cutting them in half instead of doubling. And of course, you can continue plotting those points that way so you got a good feel for the curve, and then go ahead and draw your curve in that goes to those points, and you are done with this graph.